Good afternoon. My name is Benjamin Cavada.
My name is Manuel Flores.
And my name is Gabriel Martinez. Now, this is our final math project, in which we're going to explain a case of home mortgage. The following is going to be explained. First, the graphing of the money times of how many years it's going to take for the payment. The rate of change, which tells us how much more money you can put to lower the years. Okay, for the first part of the project, we're gonna show you the graphing part. For the graphing part, we use a graphing utility called Desmos, and it shows us how to graph scales in here. So this graph represents the amount of money you pay and the amount of years it's gonna take to pay. So its x-axis is the money and y-axis it's the years. So you can see the graph you only take onto consideration from 1,000 to 1,250 to the right. So the more money you pay, the less years it's gonna take. The less money you pay, the more years it's gonna take to complete the payment. The reason why it starts in 1,250, it's because it's the less amount you can pay. So that's why it's from there to the right.
In problem B, we were given a certain amount of money that was going to be paid monthly. Once we plug in this amount into our equation, it would give us the amount of years in years of how many times you need to pay this to have the total payment, and it's 30 years. And this same amount, we multiply it times 12, which is the number of months in a year, and it would give us the yearly amount. Once we have the yearly amount, we just multiply it times 30 years, and it will give us the total amount, which is 503,434.8. In problem C, they also gave us an amount. This amount was plugged into our equation, and it gave us the amount of years it would take to pay it. This same amount was multiplied times 12, and it gave us the amount yearly of this payment. We multiply both answers, and it will give us the total payment, which is 386,492.26.
In this part, we got the instantaneous rate of change. For the instantaneous rate of change, first we got the derivative of the function, and with that derivative of the function, we plugged in the monthly payment, and with that monthly payment, we got years per dollar, which means that with each dollar we add, we will reduce 0.08 years, and here 0.02 years.